Hey everybody. So today we are talking about reaction mechanisms. So today you're going to be looking at reaction mechanisms. You're going to be able to determine the rate law from those reaction mechanisms, and you're going to be able to determine the overall reaction from these reaction mechanisms. But what are they? So reaction mechanisms, when you see a reaction such as NO2 gas and carbon monoxide gas, and it makes NO gas and CO2 gas. This is the overall reaction, but really this isn't the only thing that's happening. Most reactions you see are just kind of like the stage. There's actually a lot of stuff going on behind stage that you're not seeing. So really, when I've been showing you an overall reaction, sometimes that overall reaction has been a 1 or 2 or 3 or 4 step process, okay? So this is our overall reaction. Okay? But really, behind the scenes, we've had a first step and a second step. So the first step of this reaction would be NO2 gas plus NO2 gas, and it will form NO3 gas and NO gas. And it might say something like, this was the slow step. Okay, and then the second step of this overall reaction would have been NO3 gas and CO gas, and it will make NO2 gas and CO2 gas. And it might say this was the fast step. So really, this whole overall reaction that we see up top here is really composed of these first two reactions down here. And what we're going to be doing is we're going to be saying, what is the overall reaction? Or what is the, overall reaction, which we already know from here, but we can figure it out from this. What is our catalysts? What are our intermediates? And what is the rate law? Okay? So let's focus on what the overall reaction is. The overall reaction, if I didn't give it to you already, I could determine from these two mechanisms, these two steps of the overall reaction. And all I'd have to do that is just cross out things that are the same on both sides. So as you can see, we have an NO3 over here and an NO3 over here. I also have an NO2 right here and a NO2 right there. Now I've crossed out everything, and then if you went ahead and looked at this, you could see that I got one NO2, one CO, one CO2, and one NO. So if I just give you the mechanisms I ask you to give me the overall reaction, you're just going to cross out the stuff that's the same on both sides, and then whatever you have remaining is our overall reaction. Now let's talk about catalysts and intermediates. Catalysts are compounds that speed up the reaction, okay? That aren't in the initial part of the reaction anymore, and I'll talk about that a little bit more. Intermediates are just helpers in the middle of a reaction that are not in the beginning of the reaction. So let's talk about that. So I have a catalyst and I have an intermediate. You could have more than one intermediate, you could have more than one catalyst, okay? But in this case, our catalyst and intermediate are going to be things that we have crossed out. So our catalysts and intermediates are either going to be NO2 or NO3. Catalysts are things that are crossed out that were at the very beginning of our reaction. So if we're looking at step 1 and we look at what's at the beginning of our reaction, what was in the beginning of our reaction that got crossed out? NO2. So NO2 is our catalyst. It's something that was included at the very start of our reaction, and that helped speed it up. So in step 1, you got to look. If you see anything crossed out on that reaction side, that's a catalyst. Intermediate is anything else that is crossed out that is not in the beginning of our reaction. So if we're looking, we see that, in the later part of step 1, NO3 got crossed out, and in the beginning of step 2, NO3 got crossed out. So our intermediate is NO3 gas. So to reiterate, if you see something crossed out in the very first step on the reactant side, of a mechanism, that is a catalyst. Anything else that is crossed out later in our mechanisms, those are intermediates. Okay? So, we're going to look at this, and now we're going to determine the rate law. Remember, rate law is written as rate equals K times some sort of concentration. It could be multiple compounds, it could be one compound, and remember they can have certain exponents. And here's the thing. Our rate law is determined on the slowest mechanism. So, if I'm looking at these two steps, which one is our slow mechanism? Well, I told you, it was the slow one. So, our rate law is going to be determined on the reactants of the slowest step. So, in our slowest step, we only had NO2. Even if I crossed it out, I have to include it. And I didn't just have one NO2. How many NO2s did I have? I had 2. So that means I'm going to put a 2 on top, okay? So our rate determining step is the first step because it was the slowest, and it determines our rate law. And that's why our rate law is rate equals K concentration of NO2 squared. So it doesn't match our overall reaction. Our overall reaction, it looks like CO gas does not determine the rate at all, but NO2 seems to affect it in a second order fashion. All right, and we'll talk about this later, but in the rate law, anything in the rate law has to be in the overall reaction. So you wouldn't have anything in the rate law with NO3 in it because it's not in our overall reaction. Okay, and we'll talk about that later. So let's go ahead and let's get into a couple more examples like these so we can make sure that we really understand this stuff. Okay, so here is our next example. Here I have given you 2 intermediate steps. You could kind of tell that I gave you 2 intermediates and not an overall reaction because they say slow and fast next to them. That's really them telling you which one is the rate determining step and which one is not. So these are just 2 mechanisms. There's no overall reaction given. And what I want is I want the overall reaction. I want you to tell me if there's any catalysts or intermediates, and I want you to tell me the rate law. So one thing I just want to ask you before we get into these is what is the rate determining step? Which one determines how fast the reaction is going? The answer is your slow step. The slow one is always going to be the one that determines the rate, right? We only move as fast as our slowest teammate or our slowest person. So in this case, it's the same with mechanisms. Okay, the slowest mechanism is going to determine the overall rate for the reaction. So now let's go ahead and determine the overall reaction. And to do that, we need to start by crossing out some things, okay? So it looks like the only thing I could really cross out here that are the same on both sides is this fluorine ion here. And again, it's okay for fluorine to be by itself here. I know that's a diatomic molecule, but it's okay here because this is just intermediates. It's probably in solution or something like that. It's not going to stay F long. It's going to react right away. So just for a moment in these intermediates, it's by itself. So that's the only thing we cross out. So let's go ahead and combine these to make our overall reaction. On the left side, we got 2 NO2s, so I'm just going to put 2 NO2. I got a fluorine molecule right here. And I got 2 NO2Fs. And just to make sure, let's make sure this is balanced. Looks pretty good. Okay? So that is our overall reaction. Catalysts or intermediates. Remember, in our first step, something is crossed out in the beginning, it is a catalyst. Did we cross out anything in the beginning? No. So actually, there's no catalyst in this reaction, okay? Lots of reactions without catalysts. But is there intermediates? Is there anything else we crossed out that wasn't in the beginning that was just kind of a role player in our reaction? And that, of course, is true. We do have an intermediate, and it was fluorine. We crossed it out. It wasn't in the beginning, right? Or else it would have been a catalyst. Now let's go ahead and determine our rate law. Remember, our rate law has to include only compounds or elements that are in the overall reaction. So our rate law is only going to have NO2 or F2 in it. It could have just NO2, it could just have F2, it could have both of them. Let's see what happens. So let me start by just writing rate equals K. And remember, to determine my rate law, I gotta look at my slow step. And I just gotta look at the reactants of my slow step. In kinetics, only the reactants affect the speed. So I'm looking at these. Looks like I got NO2 and F2. It looks like they're my overall reaction, so I could use both of those guys. So my rate is gonna be NO2, F2. Okay, remember, we determine the rate law from the mechanisms, not the overall reaction. A few of you are going to look at this overall reaction and you're going to say, oh, 2NO2, I'm going to put a squared there. Nope. Okay, the overall reaction does not determine the rate law. The slow step determines the rate law. Okay, so my rate is K, NO2, F2. What order is it overall? Second. We add up those exponents, and that means it's second order overall. All right, let's go ahead and go to another example. All right, everybody, here's our next example. And in this example, I have just given you rate law, so we aren't going to have to figure that out anytime soon. And I've given you three mechanisms here, and as you can notice, I haven't given you the slow, fast indication on the right side there. So we're going to have to do some deep thinking to figure out our part A. Determine the rate determining step. Okay, which one determines how fast this goes? Which step is the slowest? Usually, you could look at this and just look at the speeds I gave you, and the slow one is the rate determining one. But in this case, I did not give that to you. So what you're going to have to do is you're going to have to look at your rate law. Remember, our rate law is determined by the rate determining step. So our rate is equal to KO2. Well, which one of these reactions has O2 in the reactant side that will match up with this rate law? Okay. If I look at step 2, there's no O2 on the left side, so it's definitely not that guy. But if I'm looking at number 1, there's O2 on the left side there. There's also O2 on the left side here. But as you can see, our rate law is to a one order. If it was 1/2, you would say it's this one, but it's not. It is this one because it's got a coefficient of 1 in front of it. So our rate determining step is step 3. So remember, if I don't give you an indication of how fast each of these mechanisms are going, you could always go back to your rate law to help you determine that. Overall reaction, so we gotta start crossing some things out, all right? I got these NO2s that can go away. I have these NOs that can go away. And it looks like I got an O over here and an O over on that side, reactant product. And I believe that's about it. So we're left with 1.5 O2s, or as I couldn't say, is 3/2 O2 gas. And it looks like we got 1 ozone, 1 O3 gas, okay? Let's make sure that matches up. Yeah, it's balanced. 3 times 2 is 6, divided by 2 is 3 oxygens. We got 3 oxygens over there. Okay, and that's good, right? Because in our overall reaction, anything on the reactant side, it does have to be in the rate law, which it shows up right there. Intermediate or catalysts. Let's determine catalysts first. Was there anything in our first step of the first reaction that got crossed out in the reactant side? Yep, NO did. So NO is a catalyst. So I'll put C, NO gas, and then everything else that got crossed out is an intermediate. So I'm seeing NO2 is an intermediate. And it's also looking like O is an intermediate as well. So I had 2 intermediates there, and that's totally fine. Okay? 1 catalyst, the thing in the beginning that got crossed out, and then 2 intermediates. Okay? So that is kind of the basics of mechanisms. But now we're going to go into writing rate laws for reaction mechanisms where they get a little bit trickier. Okay, so now for these next few examples, I'm just going to be asking for the overall reaction and the rate law. The first two are going to be easy, but then after that, it's going to be a little more difficult. So let's just go ahead and let's fly through this one. We want to determine that overall reaction. Let's just cross out everything that's the same on both sides. Dinitrogen monoxide. I believe that's it. All right, easy stuff. So our overall reaction is we got two H2s here. We got two nitrogen monoxides. And we got one N2 and two H2Os. Let's make sure that that makes sense. Yep, it looks balanced to me. Okay, and then we got to determine the rate law. Remember that the rate law is determined on the reactants in the rate determining step. Okay, so here our rate law is rate equals K. And remember that in our rate law, they have to be in the overall reaction as well. So our rate here, slow determining step, looks like H2 and NO squared. I got that written down. Let me make sure that both of those reactants are in my overall reaction. They are. So this rate law is good by me. So that is really easy one, right? It didn't mess up at all when we made our rate law. Both of those reactants were in the overall reaction. And remember to determine it on the slow step. I know some of you, again, I've said this before, are going to put a squared here by looking at the overall reaction. That is incorrect, okay? We base it off the slow step. So that was an easy example. Let's go ahead and do another quick, easy one. All right, here we go. Another reaction where I just want overall reaction and rate law. Overall reaction, let's start crossing some things out. The only thing I see is HI. Okay, same on both sides. Overall reaction, I got H2. I got two, ICLs. I got one I2, and I got two HCl's. Let's make sure that matches up. Balance-wise, yep, looks good. Rate law, okay? Let's go ahead and write our rate law based on our reactants in the slow reaction. Rate equals K, H2, and ICl. No exponents needed because there's no coefficients. I go ahead and I look at that. Got to make sure that H2 and ICl are in my overall reactions. They are. Everything is good there. So this is a good rate law because it does include the reactants in my overall reaction. Now let's do an example where we might run into an issue where we get a rate law where there isn't a reaction that's in our overall reaction. All right, everybody, here's our tricky one. This was actually an AP question a few years ago. So let's go ahead and let's determine our overall reaction. This one's pretty easy, right? We just have N2O2 and N2O2. So our overall reaction is just going to be 2NO plus O2 to 2NO2. Looks balanced to me. All right, now let's determine our rate law. Well, if our rate law is based on the slow step, I would write rate, and I'm going to include everything here, even the stuff I crossed out. K, N2O2, and O2. And then you might say, okay, cool, that's my rate law. But here's the problem. Our rate law includes a reactant that is not in our overall reaction. We can't have that. Okay, we have to have a chemical that's in here that is in our overall reaction. And you guys might just be saying, okay, just get rid of it, just cross it out. We can't do that either, okay? We have to find a replacement for it. So what we can do is we could look at our intermediates and look for something that equates to N2O2. All right, so I'm looking at this. I gotta get rid of N2O2 at some point, and I gotta replace it with something else. Well, I'm gonna look at my mechanisms and see if there's anything that's kind of comparing it to N2O2. I look down here, here's N2O2, but that also includes O2. So we can't just use that. We gotta find something that is solely N2O2. Well, if we look at our first step here, you could see that I got two NOs that are becoming N2O2. hey, we can use those NOs as a conversion for our N2O2 in our rate law. So what I'm going to do now is I'm going to write rate equals K, and for N2O2, I'm going to swap out those two NOs that helped make it. So for those two NOs, I'm going to put NO, and since I have two of them, I'm going to put a 2 as a coefficient, and then I'm going to keep my original O2 that is in my overall reaction. And now this one's okay because it matches my overall reaction. It includes those reactants that are in my overall reaction. Okay? So when we find ourselves in a situation where our rate law has a reactant that is not in our overall reaction, we'll just have to find something from our intermediates to swap it out with. Let's do one more example like this. All right, everybody. 4 steps. Okay? 1, 2, 3, 4 steps. We got to determine the overall reaction in the rate law. Let's go ahead and do this. So I'm looking, I got to make sure that I see everything. I know there's a lot going on here. Looks like I got a BR2 here and a BR2 here. I got a 2BR here, I got a 2BR here. So those two just canceled each other out entirely. I got a BR and a BR that can go. I got an H and an H that can go. Looks like that's about it. So my overall reaction is going to be BR2 plus H2 becomes 2HBr. So there's my overall reaction. It kind of bugs me that I put bromine first. It doesn't matter, but my OCD wants to flip those guys. Anyway, rate law. Let's go ahead and write our rate law based on our rate determining step. Our rate determining step is our slow one. So I'm going to write BR and H2. And then I'm going to say to myself, crap. All right? H2's in there, but BR is not. So I got to go ahead and I got to find something that clearly translates a BR to hopefully a BR2 or maybe another H2. So let's see what happens. I'm looking at my reaction. I'm looking for something that just has BR. Oh, I got this one or I got this one. We could use either one. It doesn't matter. But it looks like it both equates them back to BR2, right? I got BR here, but it's got HBr included in it, so that's not so clear cut. But what I can use is I can use this first one or this fourth one, either one. Don't use them both, just use one of them, okay? Let's focus on this guy right here. So I canceled out this BR, but that was BR squared, right? It would be BR squared in here, so it doesn't really equate all that well. But the good thing is that if I have this 2BR, BR2, I could always simplify it to help me out. I could just change it to BR equals 1/2 BR2. That's totally fine. Okay, now we have an exact match with our BR in our rate law. Okay, so now I could go ahead, I could get rid of my BR, and I could actually replace it with something that is in my overall rate law, which is BR2. I'm going to put it to the 1/2 because the coefficient is 1/2. That's okay. And I'm going to include that H2 that was in there originally. Okay? So we had to do a little manipulation here, right? The BR did equate nicely to a BR2. It wasn't an exact match. That's why I halved it in order to make it match that BR from our rate law. And then I crossed it out, and this time I included it as a 1/2 coefficient. So this is a 1.5 order reaction. Okay? It just means that BR is kind of a player, not a really big player in this reaction, not as much as H2. Okay? You don't really see these too often in real life mechanisms. Okay, that is reaction mechanisms, everybody. Make sure that you got those down. You know, rate determining step. You know how to determine catalyst and intermediate. You know how to do your overall reaction. And you know how to replace some of these rate laws with actual reactions from our mechanisms. Okay, that's it, everybody. Have yourselves a great day.